All right, so here's the homework for simplifying radicals. And you can do the homework with me, or you can check to see if you did it right. Give all possible roots to the radical equation. So roots is the idea of like if you solve the equations. When you solve and you take the square root, there are two possible answers. It could be positive or it could be negative 15. When you do the cube root, there's only one possible answer. So what number 3 times itself equals 512? Cube root, again, one possible answer, negative 4, negative 4, negative 4. And then fourth root, so an even root has two possibilities. So what's number 4 times itself that equals 1296? So it's 6, 6, 6, 6, or negative 6, negative 6. Negative 6, negative 6. All right, so can you simplify these below by using perfect squares or cube roots or things like that? So 150, what is a perfect square that goes into it evenly? And that's 100. So we could write that as, 100 times 5 does not equal that. Let's start that correctly. So what number goes in evenly? And it was 25. And that'd be 6, like 6 quarters. And the square root of 25 is 5 times the 5 in front makes it 25. Root 6. Done. All right, negative 8, 63. So the perfect square that goes into it evenly, to simplify it, is 9. And the square root of 9 is 3 times negative 8 in front, and you get negative 24 root 7. Cube root of 875. What's the perfect cube that goes in 875 evenly? So I think of 125 automatically, and that's times 7. The cube root of 125 is 5, and then what's left under the cube root sign is 7. Cube root of negative 54. So what's the cube root I think of automatically that goes into it? It would be negative 27 and times 2. So the cube root of negative 27 is negative 3 times 2, so it's negative 6, and the cube root of 2. The fourth root, perfect fourth. So 81 times 7. So what number 4 times itself equals 81? That's 3 times negative 3 is negative, there's a 4 in there. Fourth root, and 7 is left behind. Fourth root, for 405, we're going to use 81 again. This time it's 81 times 5. So the fourth root of 81 is 3, and 3 times 6 is 18. And you're left with the fourth root of 5 behind. Number 11, how do we handle variables? So when you take the square root of an exponent, you're halving it as such. And if it's an odd number, there's going to be something left behind. So let's start first of all with 252. So 252, the perfect square that goes into it evenly is 36, and it's 36 times 7. And we're going to separate k to the 5 by writing it as k to the 4th times k. So I'm picking the even number that's close to 5. So what even number is the closest to 5? And then I'm separating it with another k. So 4 plus 1 is still k to the 5. They're the same, but we do it this way so I can take the square root. So what's the square root of 36? That's 6. What's the square root of k to the 4th? Well, you divide by 2, so it's k squared. And then what's left that I couldn't take the square root of is 7 and 1k. And then 3 times 6 is 18. So that's 18k squared, 7k. Here, 60 is 15, 4, right, times 15. The variables are ready to take the square root. So the square root of 4 is 2 times 4 in front is 8. The square root of 8 to the 6th, you divide the exponent by 2 and you get a cubed. And now what's left over is 15 and b. So because b doesn't have an even exponent, it's just 1b, it stays behind. 13. So the square root of 49, I know. That's 7, 9, and then 16. So all I really need to worry about before I start is x to the 9 we'll write as to the 8 and then x, and then y to the 16. So we go to the nearest even number that's less than the odd number, and now we can do it. So the square root of 49 is 7, times 3 is 21. The square root of x to the 8th, divide by 2, and it's x to the 4th. Square root of y to the 16, divide by 2, and it's y to the 8th. And then what's left over behind is just an x. Number 14. So where you have a 2 in front, cube root, perfect cube. So it's going to be 64 times 3. The 7, now we're dividing by 3. So we're going to use p to the 6th, because we're finding the closest number to 7, that 3 goes in evenly. And that leaves me with 1p. And then 18 is fine because 3 goes into 18 evenly. So one step at a time. The cube root is 64. What number 3 times itself is 4, times the 2 in front is 8. The 3 will be left behind. Divide 6 by 3 this time, so that's squared. Divide q to the 18 divided by 3, so that's 6. And then what couldn't I take the cube root of is 3 and p. Number 15. Remember, you can take the cube root of a negative number, so that will be in front. Now, what number does 3 go into evenly? That's less than 14. So that would be 12. And then I still need a 2, so it adds up to 14. S to the 9 is good because 3 goes into 9 evenly. So when I talk about r to the 12 divided by 3, so now it's r to the 4th. S to the 9 divided by 3, so it's s cubed. And then what's left over is the cube root of r squared. Number 16, cube root of negative 625. So the perfect cube that goes into it evenly is 125, and it's negative, and that's times 5. 28, 3 goes into 27 evenly, but I still need another m. 12 is good because 3 goes into it evenly. And now the cube root. So the cube root of negative 125 is negative 5. The cube root of this divided by 3, and you get m to the 9th. The cube root of n12 divided by 3, and you get n to the 4th. And then what I didn't take out is left behind. So that's a 5 and 1m. All right, 3 left. So what number 4 times itself goes into 243 evenly? So 81. And it's 81 times 3. Now we're dividing by 4. So the nearest exponent that 4 goes into evenly would be 4. And we need another m. For 13, it would be 12. And I need another n to make 13. So now that I've broke it up, I can now take the 4th root. So the 4th root of 81 is 3. The 4th here divided by 4 gives me 1m, and 1m will be left behind. Divide this by 4 and you get n to the 3, and then that's it. What's left over that I didn't take the 4th root of is 3. There's an m and there's an n. Number 18. This one's going to be 8 times 10. Was there bigger? No, 4th cube root would be 8, sorry. 16 is the one I'm looking for. So 16 times 5, because I know the 4th root of 16. Remember, what number 4 times itself? Here, x to the 8th. Again, it needs to be divisible by 4, so x to the 8th is good. Y to the 9th, I need to break it down to y to the 8th and y, so that 4 goes into 8 evenly. And then z is what it is. So the 4th root of 16 is 2, and 2 times negative 2 is negative 4. The 5 will be behind. 8 divided by 4 is x squared. 8 divided by 4 is y squared. And that's it. What's left behind then is a 5, a y, and a z. All right, number 19. So again, the 4th root. So 112, what 4th root goes into it evenly. So that's 16 is that perfect fourth. And it's 16 times 7. 24 is good because 4 goes in it evenly. D is going to be 12 and then D, so that I have an exponent that 4 goes into evenly. And we need that extra D so it's equivalent. So the fourth root of 16 is 2 times 5 in front is 10. 24 divided by 4 is 6. 12 divided by 4 is 3. And that's it. So what did I take the fourth root of? It's a 4. That'd be 7 and 1D. All right, so there's your homework on simplifying radicals. Good job, junior work. Mr. G Math, over and out.